this video, I will be going over section 5.2, problem number 15, which asks us to find the eigenvalues of the 4x4 matrix below. So just like problem number 11, to start it off, we have to subtract the original matrix by a matrix that has eigenvalues in the diagonal row. After we do that, we'll be left with a new matrix that is 4 minus eigen, -7, 0, 2, 0, 3 minus eigen, -4, 6, 0, 0, 3 minus eigen, -8, 0, 0, 0, 1 minus eigen. Now for the next step, we're going to have to separate the original the new 4x4 matrix into 3x3 matrices, which usually we'd use the top row. However, row 4 is much simpler to use and will be much easier when getting down to the math at the bottom. So for the first, we have 0 times -1 going into 3x3 matrix of -7, 0, 2, 3 minus eigen, -4, 6, 0, 3 minus eigen, and then -8. That is added into 0 times -1 into the 3x3 matrix of 4 minus eigen, 0, 2, 0, -4, 6, 0, 3 minus eigen, and -8. Added into 0 times -1 times the 3x3 matrix of 4 minus eigen, -7, 2, 0, 3 minus eigen, 6, 6, 0, -8, plus 1 minus eigen times -1 times the 3x3 matrix of 4 minus eigen, -7, 0, 0, 3 minus eigen, 4, 0, 0, 3 minus eigen. So now, after doing all that and adding that together, we are left with 1 minus eigen times the 3x3 matrix of 4 minus eigen, -7, 0, 0, 3 minus eigen, -4, 0, 0, 3 minus eigen. Now in the last problem, this is where we were able to stop since it's a 3x3 matrix. However, since this is now a 4x4 matrix, we have to continue going and separate it now into 2x2 matrices, using that bottom row once again, as it would be much simpler than using the top row. So the first one we have is 0 times -1 times the 2x2 matrix of -7, 0, 3 minus eigen, -4, plus 0 times -1 times the 2x2 matrix of 4 minus eigen, 0, 0, -4, plus 3 minus eigen times -1 times the 2x2 matrix of 4 minus eigen, 7, 0, and 1 minus eigen, or 3 minus eigen. So from here, that leaves us with 3 minus eigen times the 2x2 matrix of 4 minus eigen, -7, 0, 3 minus eigen. So here, just as like the last problem, we will find the determinant of the 2x2 matrix, which to do that, we'll have 4 minus eigen times 3 minus eigen minus -7 times 0, which leaves us with eigen squared minus 7 eigen plus 12. So now from that point, what we'll have to do is we'll have to multiply it by 3 minus eigen, and also we cannot forget about the 1 minus eigen here that we were left with in front of the 3x3 matrix. So that will leave us with 1 minus eigen times 3 minus eigen times eigen squared minus 7 eigen plus 12, which after multiplying that together, we are left with the characteristic polynomial of eigen to the power 4 minus 11 eigen cubed plus 43 eigen squared minus 69 eigen plus 36, which now from here we just need to find the roots and we'll be left with the eigenvalues. So to make it easy, what we can look at is we can go back to the original matrix and use the diagonal row to help us solve for the problem and see which ones equate to eigenvalues. Now as we can see, once we plug in the numbers 4, 1, and 3, and we come out with, and we plug them in and we try and see if they all come out to 0, which in fact all 3 of these do, which what that means that eigenvalue 1 is 4, eigenvalue 2 is 1, and eigenvalue 3 and 4 is 3. So therefore, the eigenvalues we have is 1, 3, and 4. And that is the solution to problem number 15 of section 5.2.